Good morning, dear colleagues. Glad to participate in the conference. One of the main reasons affecting the stability of hydrocarbon raw materials production and transportation in gas industry equipment corrosion. The service life of pumping and compressor pipes in some causes is 0.5, 1.5 years instead of the planned 10 years. Downhole equipment corrosion is a complex heterogeneous process, and the complex of factors influencing both magnitude, the intensity of corrosion damage, low molecular weight water-soluble carboxylic acids plays a significant role. The purpose of the study is to identify the effect of low molecular weight water-soluble carboxylic acids on carbon dioxide corrosion of metal in gas production equipment of wells in the northeastern region of the Dnipro basin. The rate of both surface and underground well equipment corrosion depends on various factors, the main of which should be considered the aggressive components carbon dioxide and low molecular weight water-soluble carboxylic acids contained in natural gas. So natural gas, hydrocarbon condensate, formation water, and pipe steel have been chosen as the object of the study. In the low molecular weight water-soluble carboxylic acids mixture, the main component is acetic acid, which therefore has been taken further for laboratory study. Corrosion studies were carried out by gravimetric method in a thermostatic installation. The speed of stream flow in the area of placement of metal piece was 7-8 meters per second in turbulent mode. Some corrosion studies were carried out in a gas field directly in the wellhead using several methods, gravimetric and ion content. It has been established that the corrosion rate of pipe steel over solution of acetic acid in carbon dioxide is the highest, in a carbon dioxide atmosphere over distilled water is the smallest. No corrosion of steel in nitrogen atmosphere over distilled water was detected during the experiment. Stabilization of the corrosion rate in the gas phase in the carbon dioxide atmosphere after nitrogen atmosphere occurs twice as fast, then in a nitrogen atmosphere after carbon dioxide. From the given temperature and kinetic dependencies, it follows that acetic acids vapor increase carbon dioxide corrosion. However, the combined action of carbon dioxide and acetic acid causes less corrosion than acetic acid vapor. According to Kuznetsov, insoluble product of carbon dioxide corrosion located on the metal surface consists of oxide and carbonate composed of iron. It can be assumed that with the concentration of water vapor and acetic acid in the well, the destruction of protective oxide films occur according to the scheme. In an atmosphere of inert nitrogen gas, protected film do not form. Corrosion in this case occurs under the electrolyte films by an electrochemical mechanism without the formation of insoluble compounds. Thus, the influence of carboxylic acid in field well in the initial period of development is reduced to the destruction of protective carbonate films formed as a result of carbonate dioxide corrosion of the metal surface. The highest corrosion rate is at the beginning of droplet water condensation, since the main factors influencing the corrosion rate, acid concentration, and temperature greatest at this point. The presence of carboxylic acid in condensation water shifts the interval for the beginning of the aqueous fluid condensation in the well towards higher temperatures and depth compared to poor carbon dioxide corrosion. The intensity of corrosion of the well bore was determined by the gravimetric methods on a litmus sample installed in the tubing and visual on the tubing raised during repair. At these deposits, there is a correlation between the concentration of ions and the concentration of organic acids in the condensation water. It has been established that the interaction of organic acids with metal occurs in the Dnipro-Donetsk basin fields in the temperature range of 90–110 Celsius degrees and at a depth of 3,000–3,500 meters. The interval of action of organic acids on metal tubing depends on the constancy of the regime and operation time of the valve. In the constant mode, the effect of organic acids is limited to 100–150 grams. The effect of corrosion under the influence of organic acids is especially pronounced in wells where the carbon dioxide content is insignificant. Carbon dioxide pressure is less 0.02 megapascal. It should be noted that the corrosion rate of above-ground equipment is tenths of time less than that of underground equipment and 15 times less than the calculated rate for carbon dioxide corrosion determined by the Kuznetsov's equations. The slide shows the calculated at actual rate of steel corrosion at the Yablonivsky deposit. The reason for this difference was the inhibitory effects of iron salts, of organic acids, and carbon dioxide corrosion. This assumption has been confirmed by laboratory studies. It has been established that the corrosion rate in the measure taken from the well are more than 15–60 times than in the model medium under similar conditions. After treatment of the selected reservoir water with oxygen to decompose iron salts and remove iron oxides, the aggressiveness of the water condensate increases 10–15 times. For example, the corrosion rate of steel tested under the same condition in water taken from the wellhead of well number 61 of the Yablonivsky deposit after removal of iron ions increased to 14 grams per square meters an hour. The thunder salt of carboxylic acids is corrosion products during condensation of aqueous fluids in a well, subsequently inhibitors of carbon dioxide corrosion of gas industry equipment. So conclusion, firstly, the corrosive effects of organic acids entering the well along with water vapor is to simulate carbon dioxide corrosion due to the destruction of oxide protective films. Secondly, the equipment corrosion intensity is determined by the concentration of carboxylic acid in the gas, temperature, and flow rate. Maximum corrosion damage in wells is in the range of the beginning of carboxylic acid condensation. And thirdly, iron salts form as a result of corrosion during further movement in the wellbore, in plums, and communication of complex gas treatment plants are inhibitors of carbon dioxide corrosion. Thank you for your attention.